Practice test 2, question 4. Students were given a memory drug while studying for an exam. One group received the memory drug, one group received a placebo drug, one group had no treatment. Their test scores are recorded in a data box below. Is there a significant difference between the group's test scores? Test this at the 0.05 level. Okay, so this is ANOVA, what we learned last week. In this case, we are given the mean for each group. We are given the variance for each group. We are given the grand mean. And we can see that there are 5 subjects per group. So, with that said, now we are given all the information needed to solve for the mean square between and the mean square within. Please look at the step-by-step formula sheet that I posted on Blackboard. It will make this more clear. So the first thing we're going to do is we're going to get mean squares between. Okay? And that's simply n per group times the deviation of each mean from the grand mean squared divided by 2. So the best way to do this is the first function you want to do is get the deviation squared first. So here, the first mean one is 83.4 minus 50 squared equals 115.56. 50 minus 50, 0, 0 squared, 0. And 16.6 minus 50 equals 1115.56. They just happen to be the same number. Okay. Now, what you do is you take 1115.56 plus 0 plus 1115.56 divided by 2. So what's this 2? This 2 is DFB, right? DFB is simply K minus 1. K is the number of groups. So in this case, there were 3 groups. So DFB equals 2. Now, when you take this and divide by 2, you're going to get 1115.56 because these numbers are the same. There's a 0, so if you divide by 2, it's going to equal 1115.56. And then at the end, you multiply this by subjects per group, and there are 5 subjects per group. So if you do 5 times this, it equals 5577.8. Next step is mean squares within. Well, that's simply you sum up all the variances. In this case, the variances were given to you. So you add all the variances, you divide by K. K equals the total of number of groups. 3 groups divided by the sum of the variances equals 111.2. Okay, to get F critical, we need to know the 2 degrees of freedoms. All right, we know degrees of freedom B is 2 because it's simply K minus 1. Number of groups minus 1 gives you DFB. DFW, DF within groups, in this case equals 12. Why does it equal 12? Well, it's the sum of the degrees of freedom per group. If there's 5 subjects per group, the degrees of freedom per group will be 4. 4 plus 4 plus 4 equals 12, or 4 times 3 equals 12. So you have 2 and 12. Now if you go to your F table, along the horizontal plane is for degrees of freedom B. So you go to 2 and you go down the vertical plane to 12. So if you go from DF2, DFW 12, and the non-bolded number. So the non-bolded number is telling you 0.05, and the bolded numbers tell you 0.01. In this case, we're looking for 0.05. So that will come out to an F critical of 3.88. Now to get F obtained, all you need is your MSB and your MSW. We just solved for both. So you do MSB divided by MSW, which is 50.16. 50.16 is a lot bigger than 3.88. right? Because of that, we are going to reject the null hypothesis and say that there is a significant difference found in this ANOVA. Now, as far as the ANOVA tables go, forget about the total. That won't be asked on the test. That will be for chapter 13, which will be after your completion of test 2. All I want you to really understand here is we were able to get DF between, which is 2, and DF within, which is 12. We were able to get an MS between, which is this number, and MS within, which is this number. So I really just want you to understand how to get the sum of squares at this point. So all you do here is you do mean squared times degrees of freedom equals SS for the betweens, and the same is true with the withins. So SS divided by DF equals MS, and MS times DF equals SS. Also, for future reference, your F times your MS within will give you MS between as well. As far as your totals will be used for different effect sizes, which we will be completing starting next week's classes after test 2. Okay?